Welcome to myprojectbazaar.com. Our product title is Dual Bridge LLC Resonant Converter with Fixed Frequency PWM control for wide input applications. Let us see about abstract of our product. The next generation of power supplies not only has to meet the characteristics demanded by the load, but also has to process energy with high efficiency, high reliability, high power density and low cost. In order to achieve converters with high power densities, it is usually record that they operate at higher switching frequencies. In this proposed implementation is a dual bridge LLC resonant converter for wide input applications. The topology is an integration of a half bridge LLC circuit and a full bridge LLC circuit. The fixed frequency pulse width modulated control is employed and a range of twice the minimum input voltage can be covered. By applying base shift control between the primary and secondary sides of the transformer, the converter can operate at a fixed switching frequency. The converter can achieve SVS operation in the entire load range by using the magnetizing inductance of the transformer. In addition, the converter can operate with input voltage variations without penalizing the efficiency. Compared with the traditional pulse frequency modulation control, half bridge and full bridge LLC resonant converter, the voltage gain range is independent of the quality factor and the magnetizing inductor has little influence on the voltage gain, which can simplify the parameter selection process and benefit the design of magnetic components as well as over the full load range. Zero voltage switching and zero current switching can be achieved for primary switches and secondary rectifier diodes respectively. Detailed analysis on the modulation schedule and operating principle of the proposed converter is presented along with the converter performance. Next, see about flow diagram of our product. In this flow diagram, the input source is a DC supply. That DC supply is fed into converter circuit. In the converter circuit is fed to through a LLC resonant components. So it is called as LLC resonant converter. In the LLC resonant converter is getting the pulses from the PWM generator. In the PWM generator, the pulses are generated according the carrier and reference signals, and that the overall circuit consists one half bridge LLC resonant circuit and one full bridge resonant circuit. In the primary side of transformer is connected to the full bridge resonant converter circuit, and the secondary side is connected to the half bridge LLC resonant circuit side, and also the load is a resistive load. So overall circuit consists these kinds of blocks. Generally, as switching frequency increases, the switching losses associated with the turn on and turn off the devices also increases. In switch mode PWM power supplies, the switching losses can be high enough. In resonant mode power supplies, however, the switching losses can be lower, allowing the resonant converter to operate at higher frequency. Therefore, the use of resonant converter remains an interesting option for some application requiring for previous specifications. In resonant converters, MOSFET devices are appropriate for high switching frequency, with zero voltage switching is especially recommended. The overall circuits having several advantages such as high efficiency, high reliability, high power density and low cost. Next, we see about running process of our product. In this proposed implementation is done in Matlab simulating environment in the version of 2013A. First, to open the Matlab window and create the new model file. After creating that, we arranging the circuit as per the base paper. After arranging the circuit diagram, we click the run icon. Corresponding output data will be shown in the corresponding scopes. Generally, the overall architecture is a dual bridge LLC resonant converter. That means it consists of one half bridge LLC resonant converter and one full bridge resonant side converter. And in the full bridge resonant converter is connected in the primary side of the transformer, and the half bridge LLC resonant converter is connected in the secondary side of the transformer. First one, the input voltage waveform, that range is 100 volt, and next one is the input current waveform, and next one is the capacitor 1 voltage, that is input capacitor, and that is connected between the LLC resonant converter and input sources. And next one is the capacitor 2, that is C into voltage waveform. And next one is the primary side transformer voltage waveform, that is a AC waveform, and this is range is 100 to -100. And next one is the secondary side capacitor voltage, that is resonant capacitor, that range is 100 volt. And next one is the secondary side voltage is getting from the secondary side, that is 0 to 7 volt. And next one also the secondary side voltage S2 waveform. And next one is the output voltage waveform, that range is 6.5. And next one is the corresponding output current waveform. The resistance value is 100 ohms, though I is equal to V by R, so that range is 0.061 amps. And next one is the control signal. The control signal is generated from the PWM generator as per the switching manner, is depend on the carrier and reference signal. So overall efficiency will be increased due to the reducing of the current ripples in the output current and voltage sides. Thank you for watching this video.